For this lesson, our focus standard comes from Grade 8 Expressions and Equations, Standard C, Analyze and Solve Linear Equations. Our topic for this lesson comes from our unit, Simplifying and Solving Equations, and today we're talking about exploring variables and combining like terms. So our essential question is, what does it mean to combine like terms, and why is it important to solving equations? Please take a moment to copy down the header, pausing the video if you need to. Be sure to copy down today's date, set up your notes with your question column and your note column, and resume the video when you're ready to begin. So a few things should seem familiar from the last video. We talked about terms, variables, and expressions. So now we're going to look at how can we simplify them. In our textbook, when we're combining like terms, the algebraic expressions are presented in three forms. They might give us a math sentence, they might give us algebra tiles, and they might give us a written description. So we're going to do an example of each. Here's our first example. We're using a math sentence, and they're giving us 3x plus 7 plus 5x minus 3 plus 2x squared plus 3y squared. So what we need to do is look for things that are the same type of term and combine them together to simplify it. So these are the steps, and I'll explain them as we go. So the first thing we want to do is copy down the expression, because most likely we'll be reading this from a book. So I have it written down here. And we want to highlight each set of terms with a common color. So first term has x's in it. So it's a coefficient of 3 and an x. So I'm going to choose yellow for x's, and I'm going to look. Oh, here's another one with just an x in it, and it has 5 of them. It's a positive 5x. So I'll highlight that yellow as well. And then this has an x, but it's an x squared. So you might remember today when we were doing the algebra tiles for the first time, this actually looks like a square and this looks more like a rectangle. So those are different. And then I go back to the beginning and I see a 7 here, so just an integer. It's a positive 7, so now I'm going to highlight that too, but I'm going to change the color. Let's go green. So I'm going to, here also negative 3 is also just an integer, so we would see those as those unit tiles. And now I have the x squared, so I would imagine seeing 2 of those squares, and so that's different, so I'm going to highlight it blue. And a y squared is bigger than an x squared when we think about our algebra tiles. Not always, because remember these variables are just telling us it's an unknown value. And so we can use like purple for that, or pink. So those are the first 2 steps. You copy down the problem, and then you start looking for things that are the same type of term, or we call them like terms, and we highlight those. So now we're ready to combine all the things that are alike, all the things that we highlighted, those terms that are highlighted the same color. So I've started to do that. I've used parentheses to group them, and you might notice some things being moved around, and that is because in algebra we want to list the terms with the variable with the highest exponent, known as degree, first. So those little numbers above the x and the 2 and the y, that 2, those are called exponents. And so any term that has the highest one of these values goes first. The x squared and the y squared tie, so it doesn't matter which one, but they both have to be the first 2 terms. They have to be at the beginning. So we took there's only one x squared, so we put that first, so it's positive. We don't need to include that in front. And then we took the 3y squared, which was positive as well, and said plus 3y squared. And then we look at our x's, and we had a 3x and a 5x. So I used parentheses to say we're going to want to combine those together into one term. And then we used our 7, just our unit tiles, and the negative 3. And again, use parentheses to group them. And we're combining all those, so we just typically go to plus signs. And the other thing, so if the terms with the highest degree or highest exponent go first, then the terms that are just numbers go last. And so now we just need to simplify this. We've rearranged it into the groups of things that are the same, and now we need to simplify. So we keep 2x squared plus 3y squared plus 8x, because 3 x's plus 5 more x's would give us a total of 8 x's. And 7 plus a negative 3 is 4. So our final answer is 2x squared plus 3y squared plus 8x plus 4. We like this in mathematics because it tells us how many we have of each type of term and makes it easier for us to evaluate what more we might want to do with that expression. So once your notes are complete for the math sentence, let's move on to an algebra tiles example. Alright, here I'm going to explain the steps and then we'll do them. So here's an example of maybe just being given some algebra tiles. This is what we've played around with today in class. And so the very first thing is to count the number of each type of tile. So we're going to be looking at what the different types are, and we're going to count those. And then we're going to write them out as a math sentence. And then following those same things, making sure that we list the terms of the variable with the highest exponent first and list the number terms last. So I've done that right down here. So the first thing that caught my eye were the x squared tiles, these blue squares, or light blue squares, and it looks like I have 3 of those, so I wrote it as 3x squared. Then I listed out how many y squared tiles I have, these purple square ones, and I had 2 of those, so that's 2y squared. The number of x tiles, these x rectangles, so I have 1, 2, 3, 4, 4 x's, 1, 2, 3 y tiles, and xy, those are those green rectangles. I have 1 of those, so 1 xy, and then the units, the ones I have 1, 2, 3, 4, they're all positive, so I have 4 unit tiles. So I've counted up the number of each type and written them together. Now we want to write the expression as a math sentence, and remembering that the highest exponents go first and the numbers go last, which is why I usually tend to write them this way. And so when I put that all together into one expression, I have 3x squared plus 2y squared plus 4x plus 3y plus xy. I don't need to include this one. That was our little, because there's only one of them there. And multiplying by 1 doesn't change the value of anything. So plus xy plus 4. So this would be the simplified expression that represents these algebra tiles here in its most simplified form by combining all the things that are alike into one term. And so for our last example, we have a sentence written out. Suppose you put one of your x tiles and 2 unit tiles with another pile of 3 x tiles and 5 unit tiles. What is the new pile? Write it as a sum, which just means write it out like this. So it's the same steps as above. You don't have to draw it out, but you might want to. You could just make these lists based on things that you read here and list it out and count them up. But I've gone ahead and drawn it. So it talked about 1 x tile and 2 unit tiles in one pile, and 3 x tiles and 4 unit tiles in another. And we need to write this as one expression. So I have 4 x's, and I have a total of 7 unit tiles. So 4 x's and 7 unit tiles combines together to write out the expression as 4x plus 7. Again, anything with a variable and the highest exponent goes first, and the number terms go last, so it's important that we write it as 4x plus 7. This concludes our video for today, so please make sure that you have all 3 examples, including the written descriptions. Please include what the original problem is, so that it makes sense to you when you use it as an example. And once you know that your notes are all complete, start working on your study guide questions and your summary.